Let's look at some examples of multiplying polynomials. So here we have the expression 8 times, open brackets, 8k minus 8, close brackets. So strictly speaking, we're really multiplying a monomial, the 8 here, times a polynomial, or specifically a binomial. In other words, we're multiplying a monomial, an expression that has one term, times an expression that has many terms. In this case, it has two. And for that, we use something called, if you remember, the distributive law, which means we multiply the 8 times each of these expressions, right? And we have to take care of the signs. So let's begin. We have 8 times 8k. So we write our equal sign. We take care of the signs first. So since there's a positive here and there's a positive here, so it becomes positive 8 times 8, 64k. And then positive times negative gives you negative 8 times 8, 64. Now, just a quick recall. When you're multiplying integers or multiplying expressions, when the signs are the same, your answer will be positive. And when the signs are different, your answer will be negative. So in this case, positive times positive gives you positive. Negative times negative gives you positive. Positive times negative gives you negative. Negative times positive gives you negative. Okay, it's important to recall that. Alright, let's look at this other expression here. We have negative 2, 9x minus 2y. Once again, you can pause the video and try it yourselves. And then you can compare your answer with my answer. So, once again, let's take care of the signs. There's a negative here and there's a positive there. We have to use the distributive law. If it helps you, you can always draw the arrows so that you keep track of the terms that you're multiplying with. So here we have negative times positive gives you negative 2 times 9, 18x. Negative times negative, positive, 2 times 2y, 4y. Once we multiply, once we expand this expression or multiply the terms, you should always ask yourself whether we can further simplify this expression. In this case, we cannot because they are not like terms. Let's look at a few more examples. We have example C. It's negative 3 times, open bracket, negative 7a plus 5, close bracket. Once again, you can pause the video. I'm just going to move this up. You can write this down in your notes as well as a reminder, but with time and practice you get better at it. And okay, let's start looking at this example here. So once again, you take care of the signs first. Negative times negative, positive. We don't need to write it. I'll write it down for now. 3 times 7, 21a. Right? 3 times 7a gives you 21a. Negative times positive gives you negative. 3 times 5, 15. Can we further simplify this? I'll leave it up to you to figure that out. Next, D. Example. Let's look at a couple more examples. Alright. Let's look at this example here. 7n, and this one has an expression, a variable, 7n, open bracket, times 6n plus 3. Once again, we take care of the signs. So we write positive times positive, positive, 7n times 6n. So 7 times 6 gives us 42. We have to take care of the n's. So n times n squared. We add the exponents. So we always, if there's nothing written, we assume that there's an exponent of 1 on each of these. So when you multiply, you add the exponents of the variables. Okay, next, 7n times positive 3. Positive times positive, positive. 7 times 3, 21n. Can we further simplify this? No. Can we collect like terms? No. Right? No, because Even though they have the same variable, they do not have the same exponent. And let's look at one more example. Negative 10a, open bracket, a minus 3. Once again, you want to give it a try. You can stop, pause the video, and try it yourself. So negative times positive gives you negative 10a times, you can pretend that there's a 1 there, times 1a. So negative is positive, negative 10 times 1, 10. A times a gives you a squared. Negative times negative, positive. 10a times 3 gives you 30a. And that's all. If you have any more questions, you can let me know. And don't forget to subscribe.